Okay, good morning, guys. Assalamu alaikum. Welcome back to Inspire Teens, grade 11 mathematics. So in today's lesson, we'll be doing functions. Okay, so we'll be starting a new topic. I believe the last one we ended on was trig or something, but yeah, today we'll be doing. Sorry. Today we'll be doing functions. Okay, so functions is quite a long topic. I want to eventually get to doing some questions, as well as the difficult questions like vertical distance, intersection of graphs, and interval notations. I know a lot of people struggle with interval notations like f of x times g of x greater than 0, etc. Right? So, but we're going to start off with basics. Okay, we're going to start off with the basics of a straight line function. Okay, because again, these are basics, and you always have to understand the basics really well if you want to get to the complicated parts. So, straight line equation. Okay, let's look at the equation of a straight line. Y is equal to mx plus c, where m is what? We should understand m as what? M is our gradient. Okay, let's do this. Okay, m is our gradient. Okay, and what is gradient? Gradient is the slope of a curve. The slope of a curve. Okay, so essentially how steep something is, or you'll see, we'll look at it a bit more in a little diagram just now, and you guys will be able to understand it. Please keep in mind for this section, you have to know it as gradient or average gradient, because firstly, gradient, okay, gradient of a straight line, that's fine. You have a constant gradient on a straight line. That's fine because it's a straight line. However, you'll see in certain questions, you'll be dealing with a parabola graph, and they'll ask you to calculate the average gradient, and it uses the same formula. And that formula is y2 minus y1 over x2 minus x1. Okay, this is the gradient formula. Okay, then let's have a look at, so this is our straight line equation, y is equal to mx plus c, where we discussed m we said is gradient. Now, what is c? C is our y-intercept. Okay, so normally you get the y-intercept by making x0, or the x-intercept by making y0. However, on a straight line equation, if you are given the equation, you know the y-intercept directly. It's in the equation, right? So just keep that in mind. So for example, let's just say I have the equation y is equal to 2x plus 3. Y is equal to 2x plus 3. This is not extremely accurate, but let's make it, okay, whatever. Again, it's not extremely accurate, but it doesn't really matter. Well, now you can guess what this coordinate is, right? The part of the graph where it intersects with the y-axis, that's firstly the y-intercept. Secondly, we know from the equation that c is 3. So we know for sure that this is 0 and 3. Okay, always the x, remember, with the y-intercept, the x-coordinate is 0. With the x-intercept, the y-coordinate is 0. Right, we can write that here. In order to get the y-intercept, normally, we make x 0. In order to get the x-intercept, we make y 0. Okay, this applies for all graphs. Okay, however, there are alternative ways to get it. For example, in this equation, c is the y-intercept. So if the equation is given, then you do know the y-intercept. Okay, and you must know it well enough to a point where, even for example, if this is 0 and 3, you should know that c in the equation, bare minimum, you should know that this is at least equal to y is equal to mx plus 3. Okay, because you know the y-intercept. So just keep that in mind. Very important. Okay, then let's have a look at, let's discuss something. Okay, let's discuss gradient. Okay, very, 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 very important. We need to discuss gradient of vertical lines and gradient of horizontal lines. So firstly, we have a horizontal line here, and here we have a vertical line, right? Vertical. Okay, so this is what a horizontal line looks like, and that's what a vertical line looks like. So when we consider the gradient, so now this diagram is only to be talking about, we're discussing gradient. Okay, the gradient of straight lines. Okay, so the gradient, firstly, of a horizontal line, you should note, is always equal to 0. Okay, this is because it's a flat line, right? There's no incline. If you had to put a car here, that's not a car. It's not moving anyway. Okay, it has 0 gradient. It's a completely flat surface. So that car, for example, is not going to be moving anyway. So you should always remember the gradient of a horizontal line, it's a flat surface, right? So its gradient is always 0. Gradient of a horizontal line is always 0. Then when we start adding slope, okay, now the gradient starts increasing. Okay, so perhaps this has a gradient of 1. Then we can increase it a bit more. All right, maybe this has a gradient now of 3. Okay, these are not exact values, they're quite incorrect, but there's just examples. Okay, then let's just say this has a gradient of 10, right? We're going up and up and up and up. Then obviously as we go up and up and up and up, it increases 10, 11, 12, 13, 14, 15, up until forever, right? But what happens when we go completely vertical? So we increase maybe 1, 3, 10, then we increase straight up, okay, to a vertical line. And then we ask ourselves, what is the gradient of this vertical line? What is the gradient of this vertical line? Okay, is it 11 after 10? Is it 12? Is it 13? Is it 600? Is it 700? We don't know. Okay, and we cannot determine what the gradient is of that line because it's going straight up. Okay, so that's why the gradient of a vertical line, you should always remember, is undefined. So the gradient of a horizontal line, 0. The gradient of a vertical line, undefined. Okay, always remember that. Let me write that a bit neater. Okay, so gradient horizontal line, 0. Gradient of a vertical line, undefined. Always remember that, right? Those are important for us to remember. So let's discuss one more thing in terms of vertical and horizontal. Okay, if we have to consider the coordinates of the intersection of these two lines. Okay, so firstly, this is where they intersect. Okay, so as you can see, I've drawn dotted lines from the x-axis and I've drawn dotted lines from the y-axis. Okay, and the intersection points with the axes are known. So here the y intersection is known. Here the x intersection is known. Okay, and what we need to note is that along a vertical line, so what is a vertical line? This is a vertical line. Along a vertical line, okay, the x coordinate remains constant, right? Maybe it's a bit more obvious to see here, like, okay, what are the coordinates of this? Let's call this A, let's call this B, let's call this C, right? Now we ask, what are the coordinates of B, right? Maybe here it's a bit easier to see, like, okay, I can just extrapolate my x coordinate from there, it would be the same coordinate as B, and my y coordinate for there, it would be the same coordinate as B. Okay, that's important to note, that along a vertical line, the x coordinates remain the same. So this would be 5. Okay, and along a horizontal line, the y coordinates remain the same. So this would be 6. Okay, so that's just the last thing with regards to horizontal and vertical lines that we need to take note of. That's very important. Okay, let's move on. Let's talk about now, okay, it wasn't actually the last thing I lied, equation of a vertical line, equation of a horizontal line. That's something we have to discuss also. Very important. Many people confuse it and forget about it and are not 100% sure. Yeah. 1 second, sorry. And I'm not 100% sure of it, okay, but you need to be. You need to understand the equation of a vertical line or equation of a horizontal line properly, okay? And it's quite simple. So let's have a look at the equation of a vertical line. Now, remember I said that on a vertical line, all the x coordinates remain the same. So if we have to consider this line, which the x-intercept is given to us as 3, okay, and we have to consider this point here, right? Let's call it A. and let's call it B. If we have to consider their coordinates, okay, if we have to consider their coordinates, A's coordinates, we know that it would have definitely a coordinate of 3 and some positive y value, and B's coordinates would have definitely a value of 3 and some negative y coordinate, right? So that's the key thing to take away, is that on a vertical line, the x coordinate remains constant. The x coordinate remains the same. Okay, so anywhere on this vertical line, the x coordinate is what? The x coordinate is 3. So that leads us to the equation of a vertical line, and it is that x is equal to the x-intercept. Okay, so maybe this is just the easiest way to write it. X is equal to the x-intercept, or, okay, any x coordinate on that line. Any x value on the vertical line. Okay, why am I saying any x value on the vertical line? Because all the x values are the same. Okay, so the x value at the intercept is the same as the x value there or the x value there. So that's the equation. The equation of a vertical line follows x is equal to x-intercept, or any x value on that vertical line. And I'll discuss, you may be wondering, it's a straight line, why does it have the form x is equal to and not y is equal to? Okay, we'll discuss that in a bit. But first, let's have a look at this guy, which is the equation of a horizontal line. So if we look on a horizontal line and we consider points A and points B, okay, and the y-intercept is 2, so we know that A's coordinates, let's rewrite A and let's rewrite B. We know that A's coordinates, we call that A's coordinates is some negative x value, right, and 2 as a y coordinate because it's along the same horizontal line. The stream is blurry and I cannot see. It's probably not just you. Let me try and fix it. It's just my connection might be a bit unstable. Might be the problem. Let me try resharing the screen and see if I fix it. Just give me 1 second. Probably not just you, to be honest. Sure, this is going to be better, but we're going to try it. Unfortunately, you will see my whole screen, but just let me know, is this better? If not, then we'll just go back to the old method and just pray that it's better. It's just that my connection right now is not as stable. Way better. Okay, that's excellent. That is excellent. Okay, let me just reconfigure my whole life here. 1 second. Okay. Okay, I think everything should be fine. I think you guys can see me and see my screen. Let us, here we go. Okay, perfect. Okay, let us continue. So, okay, so yes, right, like I said, we were busy with, because we're discussing coordinate. Is that the time? Did our lesson start? No, time on my iPad is wrong. Some reason. Okay. Okay, so we were discussing a horizontal line, okay? And it's actually in the form y is equal to the y-intercept. Okay, we're gonna get there now. That's the equation. But we were discussing that the y coordinate on a horizontal line remains constant. So if the y-intercept here is 2, okay, the x coordinate here has some negative x value and y as a 2, or the 2 as the y value. So this is some positive x coordinate, okay, and 2 as the y value. That we know for sure because it's a horizontal line. Okay, I passed it again. Sorry. I'm just trying to think. Give me 1 second. Okay, let's just try and okay, is it somewhat doable or is it completely like just terrible? It's because my connection is really bad. If it's like somewhat doable, would it be possible for us to get away with it? Okay, what I'll try and do also is I'll try and just write a bit bigger. Mm, okay. Okay, yeah, I'll try and write a bit bigger so that it's easier to see. Okay, so yes, like I was saying, the the y value remains constant on a horizontal line. Okay, so here even, right, when we talk about the y is equal to the y-intercept or any, okay, any y value on the horizontal line. Any y value on the horizontal line, because the y value remains constant on the horizontal line. Okay, so that's the equation of a horizontal line. So for example, if you want to get the equation of this line, the equation of this line would be equal to y is equal to 2. That would be the equation of this line, because y is equal to the y-intercept, or y is equal to any y value on that point. Okay, then if you have to go back here, the equation of this line would be x. X is equal to 3. Okay, so just to quickly discuss, for the vertical line, why do we have an equation in the form of x is equal to? So remember, these are straight lines. Okay, let me. These are straight lines. Y is equal to mx plus c. Okay, so when we talk about the gradient, okay, of a, let's just say, a horizontal line, if you remember correctly, we said that the gradient of a horizontal line is equal to 0. So it becomes 0x plus c, which just becomes y is equal to c. So this is the equation of a horizontal line. Y is equal to c because its gradient will always be 0. Okay. Then let's do a vertical line. So remember, the vertical line gradient was undefined. So you cannot have something is equal to y is equal to undefined x plus c. Okay. So this equation will not make sense. That's why we write the equation in terms of x. It only has an x value. Okay. So that's just perhaps something for you to remember. Okay. Reflections we will come back to. Okay. But that's basically straight lines and vertical and horizontal lines discussed. Okay, let's move on to parabola. Okay, so parabola comes in 3 forms. Okay, that's standard, turning point form, and root form. Just have a look here. Okay, so we have standard form, turning point form, and root form. So we're going to start off with standard form. Standard form is y is equal to ax squared plus bx plus c, where again c is our y-intercept. Okay, and remember, to get the y-intercept, you make x 0. If you make x 0, you make that 0, you make that 0. So it makes sense that y is equal to c is what you're going to end up with, right? So y is equal to ax squared plus bx plus c, where c is our y-intercept. Okay, the turning point x, how do we get it? By saying negative b over 2a. Okay, so you'll see we take this b negative over 2 times that a to get the turning point x. Once we solve for the turning point y, we substitute turning point x into the main equation to get turning point y. Okay, so this is in standard form, ax squared plus bx plus c. That's how we get the turning points in that form. Y-intercept and x-intercept, you make y and x 0 respectively. Let's look at turning point form. Okay, so turning point form, we have y is equal to a, open brackets, x minus p plus q. Okay, now in this turning point form, okay, we have p and q, and p and q are the turning points. Okay, so that's why it's called turning point form. So p is actually turning point x. Okay, p is the turning point x, and q is turning point y. Okay, but one important thing about these is when we look at the equation compared to the actual graph, you'll notice that p has the opposite sign to what it has in the graph. So p, if we want to get the actual turning point x from the equation, we'll have to use the opposite sign. Okay, and with q, it's the same sign. Okay, so if we want to, for the turning point x that we get from p, turning point y we get from q. Okay, however, with p, it's always opposite sign if we're comparing the equation to the graph, and with q, it's always the same sign when we're comparing the equation to the graph. Now, let's look at an example. They say if the turning point is -3 and -4, okay, then the equation is as follows. So what would the equation be? Okay, the equation would be, firstly, I'm just going to write it in terms of a. So I'm going to have y is equal to a, open brackets, x. Now, this is turning point x, and this is turning point y, right? Because it's an xy coordinate. They tell us if the turning point is -3 and -4, then the equation is as follows. Okay, the equation is y is equal to a, open brackets, ax plus 3, opposite sign, a squared there, -4, always the same sign. So that's how it works, right? You'll notice that when it comes to x coordinates in graphs, when we compare the x coordinate in the graph to the equation, it's always opposite sign, right? Even in hyperbola and such. So in this case, that's how we would write out this specific formula. Y is equal to x plus 3, because it's minus, so we write it opposite sign, plus 3 squared minus 4, the TPY keeps the same sign. And this is the equation of the parabola function in TP form. Obviously, we'll need to solve for A, but that's not important for now. Okay, let's move on. So yes, x-intercept and y-intercept for TP form, make y0, make x0 respectively. That does not change. Root form, okay, x-intercepts or x-intercept form. So root form is also known as x-intercept form. When we talk about the roots of a function, we talk about its x-intercepts. Okay, when we talk about the roots of a function, we talk about its x-intercepts, where it intersects the graph on the where it intersects the x-axis, where the graph intersects the x-axis. Okay, so both of these we should note. So this actually gives us, in our equation, which is y is equal to a, x minus x1, x minus x2. This gives us the x-intercept 1. This gives us the x-intercept 2. Okay, and they both opposite signs. So both the ones that are given in here, they are opposite to what they are in the actual graph, opposite signs. Okay, mathematical signs. Okay, plus or minus basically. Okay, so they both opposite signs. Whatever they are in the function, they'll be the opposite sign in the actual diagram. Okay, so let's look at an example again of just quickly how to draw up this equation. So if I have this type of parabola graph, okay, and it has an x-intercept -1 and an x-intercept of +2, I can write out the equation. So in terms of A again, I'm going to have x. So I'm going to write my first intercept, and I need to know that both are opposite signs. So this will become x plus 1 and x minus 2. There we go. Okay. X plus 1, x minus 2. So that's what I mean when I say opposite signs, right? So that's important for us to note. Then we're going to talk about the axis of symmetry, okay, on a parabola graph. Okay, now one thing we need to note that the axis of symmetry, okay, it's a vertical axis of symmetry on the parabola graph, and it is created by the x turning point, obviously the coordinate of the x turning point. Okay, so the axis of symmetry is created by the x turning point. Very important. Okay, so basically the turning point is somewhere along here where the graph turns. Okay, and its x-intercept is something like this. Obviously, this is not a perfect diagram, so it might not look like a perfect axis of symmetry, but something like that is what the axis of symmetry is. It's a bit skew. Try and make it a bit more straight. I'm sitting at an angle. Okay, that is straight, but clearly you can see that the graph is not so perfect. So it kind of doesn't look like an axis of symmetry. But on a perfectly drawn parabola graph, you will always have that as an axis of symmetry. And it's always going to be the x turning point that creates that axis of symmetry. Okay, so that's the first thing we're going to note here is that, okay, so that's the axis of symmetry is the x turning point. The second thing, very important, is the fact that the x turning point, so we're learning two things about our x turning point. It is the axis of symmetry, and it is also the midpoint of the x-intercepts. It is the midpoint of the x-intercepts. So basically, from here to here, okay, that from from x-intercept to turning point, and then from turning point again to x-intercept are equal in length. So that means that this point here, the x turning point, is the midpoint of the intercepts. So we can calculate the x turning point in this way as well. So in this case, if you are given this equation, there's no need to use negative b over 2a. Firstly, it's not in the form ax squared plus bx plus c. It's in this form. So you can simply calculate the midpoint of your x intercepts, and that will give you the x turning point. So this is another way to calculate x turning point. Okay, so just keep that in mind. XTP is the midpoint of the x-intercepts. So in this case, I could calculate the specific x turning point. XTP, that's a bit small, sorry, is equal to -4 plus 1 over 2, which is equal to -3 over 2. Okay, so the x turning point here is -3 over 2, and some y coordinate, which we're not going to get because we can't even get because we don't even have the equation. Right, the way to get the y TP would then just be to sub this into the original equation, which we don't have. So it's fine, -3/2 and y. Okay, so now the axis of symmetry, we can discuss what? We can discuss the equation of the axis of symmetry. Okay, and since we know, so the axis of symmetry is a vertical line. Okay, and it's not just any vertical line, it's the vertical line which is the x turning point. Okay, the x turning point. And again, it's a vertical line, and we have the x coordinate of that vertical line. It's the x turning point, -3/2. And if we have to, that's why we have to understand this once again. What is the equation of a vertical line? It's x is equal to its x-intercept or any x value on that vertical line. And in this case, any x value is -3/2. So the equation of the axis of symmetry, because they could ask that, is x. Let's do it like this. X is equal to -3/2. Okay, so please keep that in mind. So all of that knowledge that we have to learn about vertical and horizontal line comes into play here, and we understand it. So things we just learned: axis of symmetry is the x turning point. We can get the x turning point by calculating the midpoint of the x-intercepts. And equation, right? Equations always has to have that equal to sign. This is a vertical line, so therefore it takes the form x is equal to whatever the value of the x coordinate on that vertical line is, and in this case, it's x is equal to -3/2. Okay, so I hope that makes sense. Please ask any questions if you guys don't understand, but for the most part, I think most of you guys should understand. Okay, let's have a look at this, and let's try to go through this as quickly as possible, right? So let's talk about the shape of parabola graphs. Oh, my time fixed itself somehow. Let's talk about the shape of parabola graphs. Okay, so let's talk about A firstly. Please note that A is found in every single equation. Every parabola equation has A. So let's look at it, right? So the first equation is A x squared plus bx plus c. Then the second equation that we learned is A x plus x minus p, x minus p squared plus q. And the third equation is A into x minus x1, x minus x2. So A is in all three equations, and A helps us to determine the shape. When A is greater than 0, we have a happy smiley face. Okay, and what's also important to note is when A is greater than 0, when we have a smiley face, the graph has a minimum value. It has a minimum value, which is this guy here. Okay, please note that it has a minimum value. It doesn't have a maximum because you can see it goes forever, right? The smiley face graph goes forever up, so it doesn't have a maximum. Then when we talk about A is less than 0, that's a sad face, and the sad face has a maximum. It doesn't go forever up. It has a limit on top. However, it goes forever down, so it doesn't have a minimum. It has a maximum, but no minimum. Okay, so please keep that in mind. Let's just talk about increasing and decreasing really quickly. So this is when A is greater than 0. We'll discuss this in more detail later on. But for now, okay, A is greater. This is an example of A is greater than 0. This is just a parabola function. I don't know what's going on here, whatever. Okay, so we have Bob. Okay, Bob is chilling over here. And just to discuss, right, increasing and decreasing, we always work from left to right. So many people might look at a certain graph and then they can't determine, is that increasing? Is it decreasing? I can't really tell, because if I look from left to right, it's kind of increasing. But if I look from right to left, it's kind of decreasing. That we stop that confusion. Always look left to right. Always look left to right. Is the graph going up or is the graph going down? If it's going up, it's increasing. If it's going down, it's decreasing. As simple as that. Okay, so we always look left to right. So if we look at little Bob here, let's take this away. Okay, Bob is going left to right, always left to right. Bob never goes right to left. Bob always goes left to right. Okay, now initially Bob is going, he's always going left to right. So for the initial part of the graph, he'd be going down this parabola, of course. So that's when this guy, this function is decreasing. Okay, whenever Bob is basically about to die because he's sliding down this parabola all the way up until this point, that is when the parabola graph is decreasing. Then finally, Bob makes it to the little valley here at the bottom, and now he has to make his way all the way up, and that's when this graph is increasing, when Bob has to climb up the graph. When he has to climb up the parabola, that's when the graph is increasing. So that's just a side note. Again, we'll go through this more in detail and discuss it, because they do ask questions like, give us the interval for which this graph is increasing, or give us the interval for which this graph is decreasing, right? So yes, that's just for parabola for now. Let's try and draw a quick graph, right? It's be like 5. Let's give ourselves a time for this. So let's hope we can be done by 40 with this specifically. So we have an equation, f of x is equal to 2x squared plus 3x minus 5. This is a parabola equation. We should note that this is a parabola equation. At the end, I'll just make a side note of how do you determine, maybe sometimes you're given an equation, they don't tell you it's parabola, they don't tell you it's exponential, they don't tell you it's hyperbola. How do you determine what type of graph it is? Again, I'll make a side note in the end for all of them, but for now, how do we determine it's a parabola? When the highest exponent of x is 2, that's generally when it can be a parabola. Okay, you'll see others, like if it's in the denominator, hyperbola. If there's x in the exponent, it's exponential. But for now, when the highest power, so sometimes you could have an f of x graph that looks like this. F of x is equal to 3x squared. Doesn't have all the other things, but it's still a parabola function. Or 3x squared minus 2. It doesn't have the x term, but it's still a parabola. Or 3x squared minus 2x. Doesn't have the constant term, but it's still a parabola. As long as we have that x term, we are in parabola territory. So the first thing is to determine the shape is A. Determine the shape using A. So is A greater than 0? Is A less than 0? Identify this form of the equation. The form of the equation is standard form. We can see that this is therefore A. A is greater than 0, which means that we have a smiley face graph. Okay, so here we're going to have something that looks smiley. Okay, next determine x and y intercepts. So x and y intercepts, that's simple, because in order to determine the x-intercept, okay, we need to make y 0. So let's make y 0, okay? So we're basically going to say 2x, because remember, this is f of x is equal to 2x squared plus 3x minus 5. It's the same thing as y is equal to 2x squared plus 3x minus 5. We're not going to be able to finish at 40, but nevertheless, 2x squared, I forgot already what it is, 2x squared plus 3x minus 5, 2x squared plus 3x minus 5. We equate this to 0, and we factorize, right? Okay, so here we're going to factorize. We're going to have 2x. Let's see if I can cheat. 2x plus 5 and x minus 1. So therefore, x is equal to negative 5 over 2, which is 2,5, or x is equal to 1. Okay, so the coordinates, by the way, if you wanted to note the coordinates of the x-intercepts, you would have negative 2,5 and 0, right? Remember, people always try to confuse. They try to mix the x-intercepts and y-intercepts. No, x-intercept y coordinate is always 0. Y-intercept x coordinate is always 0, or 1 and 0. Okay, so just keep that in mind. Right. Then we need to get the y-intercept. Okay, so the y-intercept can make x equal to 0. Okay, so this is much simpler. Or you can even just get it from c, right? If whatever c is actually minus 5. Right, I'm just going to draw it out because we already committed. Plus 3 into 0 minus 5 is equal to y. Therefore, the y-intercept is equal to negative 5. So the y-intercept coordinate is 0 and minus 5. Okay, so y-intercept and x-intercept done. Let's get the next thing, which is turning point x and turning point y. So turning point x from standard form, if you remember from the steps that we followed, we do negative b over 2a. And turning point y, we substitute negative b over 2a into the original equation. So negative b over 2a. So this is equal to negative 3 over 2 times 2, which is equal to negative 3 over 4. Okay, and turning point x, when I sub it into the coordinates, so negative 3 over 4 is also negative 0.75. Okay, when I sub this into my original equation, so for TPY, I say 2 open brackets negative, let's just do 3/4. Okay, sorry if it's not so neat. Plus 3 into negative 3/4 minus 5. Okay, and then I get TPY eventually as negative 6,125. So the turning point coordinates are negative 0,75 and negative 6,125. Okay, weird graph, but yes, that's how we draw a parabola. X, determine the shape, and then determine x-intercepts, y-intercepts, then determine TPX and TPY. So when we have to draw it, okay, x-intercept is negative 2,5 and 1. Let's make it quite a big scale. Negative 2,5, let's put it there, and 1 would be here somewhere then. All right, let's draw that in, negative 2,5 and 1, okay. Then we have turning point, which is negative 0,75 and negative 6,125. So let's put that all the way down here. Okay, let's try and get the middle of this. Okay, let's put that all the way down here. Okay, it's not perfect, not accurate, but I don't care. Okay, and let's just copy this in here. This is the turning points coordinates. It's those two. And anything else? Not really. Now we can just draw it in. We know that it's a happy face. We have our x-intercepts. We have our turning point. We have our y-intercept, which we forgot to fill in, but I'll fill in now. Y-intercept, y-intercept. Y-intercept, it's negative. And that works, that's fine. All right, just give me 1 second. I'm just going to mute, I'll be back. Okay, so yes, then that's how the equation looks, and then we'll just say that negative 5 is here. So x-intercept, y-intercept, turning points, done. That's how you draw a parabola graph. Okay, obviously that's in standard form. There's also other ways, like you just need to work with turning points and x-intercept using the other forms. Okay, let's have a look at domain and range. Now, this is very important for us to understand, right? Understanding how to work our way around the Cartesian plane and understanding how far in terms of x values and what in terms of y values. So firstly, when we talk about domain, okay, we talk about x values. Okay, and when we talk about x values, essentially we should understand we're talking about how far left does the graph go, how far left, okay, and also how far right, because that's how x values, how far right, that's how x values work on a Cartesian plane, right? If we look at a Cartesian plane, x values go to the right and they go to the left. So when we talk about domain, when we talk about x values, we talk about how far left, how far right. Then when we talk about range, we're talking about y values. Okay, and then essentially we're asking ourselves the question, if we're talking specifically about range, how far up does the graph go? How far up? Okay, and then we're asking ourselves the question, how far down? How far down does the graph go? Okay, so that's domain and range when we're talking about just x values of domain and y values of range. Always note, domain is x values, range is y values. Okay, how far up, how far down, how far right, how far left, how far up, how far down, right? That's the important thing to know. Okay, so now let's talk about the domain in terms of its x values, specifically about the parabola. Okay, so the first method we're going to learn is this interval method. Okay, and what you should always note is that in this interval method, firstly, the domain is going to be x is an element of, okay, because we're working with x value. So x is an element of, it starts here and ends here. So the thing you need to note is this is always the start value, and this is always the ending value of the domain and range, and this is always the start value of the range, and then this is always the end value of the range, right? So that's the first thing that's important for us to know. Okay, we're talking about the domain again. X values, X is an element of the starting X value, the ending X value, that's obvious. Okay, so technically the starting value is going to be the most left value, and the ending value for domain is going to be the most right value. And this doesn't just apply for parabola, okay? This applies for all graphs. Okay, so the start value is going to be the most left value because it's X value. So it has to be left and right, right? That's how we start is left, end is right. Okay, and then for the range, okay, the start has to be the lowest value, like as in the most bottom value, and the end has to be the highest value, as in high, right? Up or down. So the bottom, up and down, the downest value and the uppest value, if we don't speak English, right? So again, that's just explaining these intervals, right, to make it easier, because it might seem easy for domain or range, but maybe this would help you understand it better when it comes to intervals, right? Understanding what this actually means, right? The X values. X is an element of the start value, the end value. In terms of domain, most left value and most right value that you're talking about within your whatever your interval is. Then when it comes to range, start value and end value, we're talking about the lowest value and the highest value in your particular range. Okay, so let's look at this graph, okay, and let's try and determine the domain of this parabola graph specifically, number one. So when we talk about domain, again, I'm going to give the first answer in terms of the intervals, okay? So when we discuss intervals, we need a start value and we need an end value. And when it comes to domain, start value is always the most left value, and end value is always the most right value. So let's look at the most left value on this graph. So if we have to follow this graph, so clearly this graph is going up and left forever, right? This graph is going up and left forever. It's just continuing diagonally. I don't know which way would it be for you, but it's continuing diagonally that way. Okay, so its left value actually goes on forever. Its most left value, sorry, goes on forever. It goes on till negative infinity. So that's how we start this off. We would say for the domain of this parabola, X is an element of. Now you'll see we learned this also again properly when we do interval notation, but we cannot include infinity. So this is inclusive, right? And then we have this as including inclusivity, and then this as exclude. Okay, again, we'll do this later on as well. And then things we need to note, infinity slash negative infinity, we always exclude. Okay, we never can include infinity, because if you're including infinity, what are you including? Are you implying that infinity has a value of 1,000,000, 6 billion? Infinity does not have a value, it continues forever. You can't include something that continues forever. Okay, so you would say X is an element of, the X values go till negative infinity. So again, you don't even have to use those terms. You can ask yourself, how left does the graph go? So our start value is actually negative infinity. It's kind of weird, but it kind of makes sense, right? Because this graph goes on forever left. So it kind of starts at negative infinity, even though negative infinity is not actually a value, but it kind of makes sense, right? And that's why we don't include infinity, right? But somewhere, if we ever do reach negative infinity, it would start there, okay, if that were a possibility. So it starts at negative infinity, which is the most left value. Then we look at this graph. Again, we're answering the question, what is the domain, which is X values, which is a start X value and an end X value, which is a most left value and a most right value. So now we've done the most left value. Let's discuss the most right value. The most right value, this graph goes on forever up and forever right. It's diagonal, okay? So again, for this one, it's the most right value is positive infinity this time. So this graph starts at negative infinity and ends at positive infinity. Okay, so for those of you who struggle with intervals or these specific questions, maybe domain, range, intervals, or the other fancy ones, I would recommend that you follow this interval notation first, okay? Because obviously most people, I think, don't use interval notation because it's longer, okay? And then the other way I'll show you in terms of, sorry, this interval? Yeah, this is the intervals. Most people use the inequality method, okay? So that's how we'd answer the domain for the specific parabola graph. Or the other way we can express this, because all the real numbers are here, right, from negative infinity to positive infinity. Whenever that's the case, we call this, we say x is an element of real numbers. Okay, so that's the other way to write the domain of parabola. X is an element of real numbers, and this is constant, by the way. This is for every single parabola. Parabolas don't change in their domains. Okay, x is an element of, this is a constant domain for a parabola graph. Okay, I know time is up, but I just would like to quickly discuss the range. Okay, so now that's domain, right? Let's talk about range. Let's shuffle things around a little bit. Okay, it's fine. Okay, we already discussed this. We wrote it twice, but it's fine. Okay, now let's discuss the range. Okay, let's work with it here first. Let's talk about, okay, this exact thing. Y is an element of. So I need to get my, okay, I don't know whether it's including or excluding for now, but how do I identify my range of my graph? I need to have start value and end value, my lowest value and my highest value. This is expressing it in terms of Y. So let me go to my graph and look for my lowest value. So if I look for my lowest value, I will see that the lowest value is at this point here. So I'm just going to give you this coordinate because it should be given. It's -1 and -5. Okay, so my lowest value, and again, when we're talking about lowest, we are definitely talking about Y. So I need to look for a Y value. So my lowest value is going to be a Y value. So the lowest value here is -5, okay, in terms of a Y value. So, and you should include it because that's part of the graph. -5 is part of the graph. So the lowest value is -5. What about the highest value? The highest value, okay, if I follow my graph upwards, okay, in the up direction, the highest value, because we know this graph is going forever, go positive infinity upwards and rightwards. So the highest value is therefore positive infinity. And I cannot include infinity. It's not something that I can include. So I don't include infinity. So this is the range of my graph. Y is an element of starting at -5, its lowest value, and ending at positive infinity. Okay. And in terms of interval notation, I could answer this. Y is greater than or equal to -5. Okay. Now this I can't explain to you. This you have to understand is the concept of it. Right. That's why if you're struggling with these, I would prefer you use interval method because this is something I can explain to you. Okay, the interval, the interval notation. Okay, compared to the inequality notation, where it's understanding, looking at the graph and saying, okay, what is my range? My range is everything greater than -5, including -5, because -5 is part of the graph. It's this point here. So yeah, that's okay. Yeah, and that's what the range is asking. What are all the Y values of this specific graph? And yes, that's how I would answer it. Y is an element of starting at -5 and it ends at positive infinity. That's a clearly defined range, okay, that you can see in the graph in terms of Y values. Okay, and then that's how you express it in the inequality. If you prefer inequalities, you may use that. Okay, right here, next time when I see you guys, we shall continue with there's also standards if you want to by heart. Some people prefer to by heart. There are standard answers that you could memorize for every single parabola, just a standardized way of answering domain and range. So for domain, this will always be your answer for a parabola graph, right? A regular parabola function. And then we'll discuss range the next time when I see you. But for now, this is the range of the current graph that we're working with. Y is an element of the start value and the end value. Okay, so that's domain and range of parabola. Again, next time when I see you guys, we will continue and just finish this little part up here. Okay, and then converting to standard form, and then we'll continue with hyperbola, right? Like I said, functions is a really intricate section, which I like to go into grave detail with so that you guys can understand all the nitty-gritties of it. And it leads up to you understanding the hardest part of it, which is for most people, those interval questions, f of x times g of x greater than 0 and all of that. Hopefully, all of the understanding of all of this will help us there. But yeah. Okay, cool. Let us end it there. Thank you guys so much for joining. Sorry for taking a bit more time. Sorry for all the technical issues. But yeah, hopefully I will see you guys next week. Have a good week and assalamu alaikum. Jazakallah khair.